Alright guys, today we are going to solve LeetCode number 198 house robber, and what we are trying to solve is there is a robber who want to rob a house in a community and maximize the amount he can rob in that community, and the catch is that he cannot rob a house next to each other. That means if a robber robs the first house, then he cannot rob second house because it's right next to it, and the next he can rob is the third house in the list. And in this example, what we can see is that robbing the house at index 0 and index 2 add up to 1 plus 3 4, and robbing the house at index 1 and index 4 add up to 2 plus 1 equals to 3, which is less than 4. So the result that we return is 4. To make it easy to understand, I have drawn houses with the amount you can rob on the top and the indexes below. So what I have to figure out is what would be the max amount that I can get by either excluding the first house or including the first house. If I include the first house, then I can start from the second index. If I exclude the first house, then I can start from the first index. So that means, so if I include the first house, then what I can do is I can get the total amount that can be robbed from including this house and add the value of this 200 on top of that, or I don't add this and I get the value that I can get from robbing the house next to it. So basically I cannot add it here, so whatever I get from all other scenarios behind me, then that would be the answer. So let's try to visualize a solution in recursion. As we discussed earlier, so if we take 2, then we will add 2 and exclude the next element, which is 7, and send the remaining list down this path. So it would be a plus 2 and we say 9 3 1. If we exclude 2, then what we can deal with is we don't add anything, so it's plus 0, and we get value 7 9 3 1 on this side. So now we are going to repeat again. We are at 9, so either we have to take 9 or not take the 9. So if we do this, it's going to be plus 9 here, and we are going to exclude the next element and include everything else. So we got 1, and in this side we got 3 and 1, but we are adding 0 here. Now there, in this scenario we have 1 to play with, so what we are going to do is we definitely are going to include 1, and then this is going to be empty. So if we add 2 plus 9 11, 11 plus 1, that is 12, and since this is empty, this could be one of the value. And if we go to the red side, we didn't add anything, so 11 plus 0, it's gonna be 11. So this is definitely not maximum because we already saw 12 here. And it can happen same thing over this side, and this gonna be this way. We have some here and then this way as well, but you get the intuition. And now from here we can see that now over here, if we take 3, plus 2 is coming here, so plus 2 was 2, 2 plus 0 is still 2. Now since we are taking 3, we add 3 here, and there is empty list because 1 is the next one, we cannot check that. But if we exclude, then there will be 0, and then we are sending 1. Now if you see here, we can see some overlapping problems, like this one will have something going down, and also if you check here, this one had the same thing. So we can see there are overlapping subproblems. So definitely we can use dynamic programming, and this problem is a dynamic programming problem. So I try to solve in the recursive way first. This is a top-down approach, and let's try to code it. And I'm gonna write a dynamic programming way also. Wait for that video. Now let's go ahead and write the code. First of all, let's define a function called DFS, and which is taking the index, and we have to have a base case for recursion to end. So that would be if index is greater than or equals to the length of nums, then we are going to return 0. Else we will return the maximum of either the neighbor, which is at index plus 1, or the sum of the neighbor right next to our neighbor, which is at index plus 2 plus nums of index, that is the amount that can be route from the current house. And this should work, but the problem here is that this would, since we are exploring all the possible scenarios at brute force way, this would exceed the time limit. So we have to use memoization. So memoization is basically saving already explored path in the hash map, and let's call it memo, and define an empty hash map, and we will check if index is already in memo, then we are going to go ahead and return the value that the hash map is storing. Other than that, it should be fine. And also we are not directly returning it. Before returning the max value, we are going to save it in the hash map, and then we will return so that we can use that for future reference. And we can just do this. Okay, so this looks like it would work. I am doing this way. I'm increasing the index. You could do it decreasing the index, like doing it from the right hand side, but I prefer this way. So, and I can go ahead and just run the outer loop starting from the index 0. That way we start our recursion. Let's go ahead and run the code. These are the passing test cases, and let's submit it. Yeah, so seems like it's pretty fast. It's working, and it's not limiting, it's not exceeding the time limit, which has happened to me before. But yeah, memoization helps it. There is a way you can use a bottom-up dynamic programming, but I can explain it later on other videos.